Hello everybody. Today we're going to talk about expanding logarithmic expressions, and we're going to use the three rules that we learned about previously. The product rule, which says if you have the log of a product, you can change it to the log of each factor and take the sum. The quotient rule, which says if you have a log of a quotient, you can change that into the subtraction of the log of the numerator and the log of the denominator. And then the power rule, which says if you take the log of something being raised to a power, you can move that power out front and multiply. So let's get to work. For the first example, we have the log base b of ac cubed. Now, that 3 is just with the c. I have the log of a product, so I'm going to use the product rule first, and I can think of this as the log base b of a plus the log base b of c to the third power. So I have these two factors, so I can change it to adding the log of each factor. And then since c has a power of 3, I can use the power rule and move that out front. So that'll be the log base b of a plus 3 times the log base b of c. And that's as far as I can simplify that one. All right, let's do another one. For this one, we have the log base 5 of 9 times 13 divided by 11. So first I'm going to use the quotient rule, and we can think of this as the log base 5 of 9 times 13, that's your numerator, minus the log base 5 of 11. All right, so I use the quotient rule, and here I have a product, so I'm going to use the product rule. So this would be the log base 5 of 9 plus the log base 5 of 13. And I'm just going to bring down minus the log base 5 of 11. And that's as far as I can simplify that one, so I'm finished. Let's look at another one. We have the log base 3 of x cubed divided by y to the 5th. So again, I'm going to start with using the quotient rule. So this would be the log base 3 of the numerator minus the log base 3 of the denominator. All right, both of these have power, so I'm going to use the power rule and move them out front. So that would be 3 times the log base 3 of x minus 5 times the log base 3 of y. All right, and I can't simplify that anymore, so I'm finished. Let's do another one. All right, we have the log base 4 of x minus 7 divided by x to the 9th. So first I'm going to use the quotient rule, and this would be the log base 4 of x minus 7 minus the log base 4 of x to the 9th, so the numerator and the denominator. All right, this has a power, so I'm going to use the power rule and move it out front. So this would be the log base 4 of x minus 7 minus 9 times the log base 4 of x. And I can't simplify that anymore, so I am finished. All right, let's look at the next one. We have the log base 6 of the square root of 12y. So the first thing I'm going to do is change that square root to an exponent. So that would be 12y raised to the 1/2 power. And now I'm going to use the power rule and move that exponent out front. So we have 1/2 times the log base 6 of 12y. So remember, when I evaluate that 1/2 is going to go with both of those. So now I'm going to use the product rule, and this will be 1/2 times the log base 6 of 12 plus the log base 6 of y. So I took this product and changed it to a sum with the log of each factor. All right, and I can't simplify this and I can't simplify this, so I'm going to go ahead and just use old school distributive property. And that'll be 1/2 the log base 6 of 12 plus 1/2 the log base 6 of y. All right, let's do another one. Practice makes perfect, people. All right, for this one, we have the log base b of x times the square root of z squared. All right, so the first thing I'm going to do is use the power rule and pull that out front. So we have 2 times the log base b of x, and I'm going to go ahead and also change the square root of z to the 1/2 power. All right, and that's times this whole thing. And now here we have a product, so I'm going to use the product rule. So that'll be 2 times the log base b of x plus the log base b of z to the 1/2 power. All right, I'm going to use the power rule again and move this 1/2 out front. So that'll be 2 times the log base b of x plus 1/2 times the log base b of z. All right, there's nothing else I can simplify in here, so I'm going to use the distributive property and distribute that too. So that'll be 2 times the log base b of x plus, now here you have 2 times 1/2, which is just 1, right? So that would be 1 times the log base b of z. And you guys can probably do multiple properties at one time. I just wanted to break it down and use one at a time. All right, let's look at another example. We have the log base 5 of 25 over y raised to the 3rd power. So first I'm going to use the power rule and move that 3 out front. So that'll be 3 times the log base 5 of 25 over y. All right, well here we have a ratio, so I'm going to use the quotient rule. So that'll be 3 times the log base 5 of 25 minus the log base 5 of y. And we can actually simplify this, right, a little bit. The log base 5 is 25. We can evaluate that. What would the log base 5 of 25 be? 5 to the what gives me 25? 5 to the 2nd power gives me 25. All right, and then we use the distributive property. And we'll have 3 times 2 minus 3 times the log base 5 of y. And 3 times 2 is, of course, just 6. And that's it for that one. I want to do one more. Wouldn't be complete without a natural log. So we have the natural log of 10 over e raised to the 3rd power. So first I'm going to use the power rule and move that out front. So that'll be 3 times the natural log, of 10 over e. All right, and then since we can use the quotient rule here, so that'll be 3 times the natural log of 10 minus the natural log of e. All right, and the natural log of e is one of your basic log properties. What would that equal? That would be 1. And now I'll just use the distributive property. So we have 3 times the natural log of 10 minus 3 times 1 is 3. All right, I hope you guys have a wonderful rest of the day and good luck on your assignment tomorrow.